Okay. Let me share computer audio or attempt to share computer sound. This will be, I have an option here for mono and stereo. Stereo is high fidelity. Okay. Um, Anyways, after way too much time, got the Fourier transform working in the way that I expected it to without having to apply any envelope functions, or I think that's what they're called. Functions that smooth out real world data so that you don't see unexpected things in a Fourier transform. Um, so this was a high pitched whistle lasting less than a second. A whistle by me, a little over 1,000 hertz sounds reasonable. This is a low pitched whistle, lower pitched whistle. This seems like a reasonable frequency value. I did have to use a Jupyter notebook, which you can get at by opening up the command prompt. I had to do pip install Jupyter, pip install Jupyter, or something like this, spelled with a Y. So if you type the command in the command prompt, Jupyter notebook, that will open up this instance of a web page. Let me do this again. So it opens up this web page, which displays the directories on my hard drive. It's a local host, so it's on this machine. And in the downloads folder, I have some Jupyter notebooks, IPy, Y, and B. These can be converted to Python files, as I did right here, ftstuff.py. If you look up conversion of Python notebook to py, there are options for it. Again, in the command prompt, there's some command that converts IPy in B, which is sort of an XML, HTML type file with tags. It looks like this. And if we open this up in a text editor, it's by default set to open with VS Code. But if we open it up in Notepad++, it's okay, so not XML, but like a JSON type file. And at some point in here, okay, yeah, there is code, but parsing through it and getting be kind of a, very loosely speaking, a fun thing to do, to parse through that to get the source code, but it's labeled source here. Anyways, I think I already made the point that I wanted to make. It's nice to finally see this. I didn't plot the sound waves, but that's straightforward to do. It was irritating that I had to resort to Jupyter notebooks. I did run this code in ignore the N1, N2 business inputs. That's for the conversion. But when I try to run this in PyCharm, something about my environment setup is funny, and I get this damn error saying a module was compiled using NumPy version 1, cannot be run in version 2, and that has to do with this librosa. And I believe I did, yeah, I pip installed librosa. Librosa is a library that's I haven't looked into it a lot, but it's designed to handle audio files. There's this call load, which stores the this file path, the base folder, which is here, and concatenates it. Loosely speaking, this join function concatenates the two strings, which are file path and a file name. And SR is the sample rate. This is the data, the sound wave data, and we call FFT.FFT. So yeah, I tried to do this in a different way earlier, which made good sense, which is why it's irritating that I had to take a different approach. Yeah, this all made pretty good sense. I commented all the code out, so it's a little more difficult to read. But the outputs of this were, let's see those outputs again. That's where I was. No, no such directory. That's because I've changed the file path. This ASDF blah 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 is in a different place. It's looking for violin C, and it's also going to look for this guy. And I'll put violin C in here. And you copy that, and it needs to be here, here. I think this area should go away now. I remove the folder. Okay. Ignoring a chunk that it didn't understand. This is just a warning. Okay, and now we've got this file was not found as expected. That was on line number 674 of some other file, the WAV file.p, but line number 13 of this file. 13. Okay. 220 quarter second, 0.1 amplitude. 220 quarter second, 0.1 amplitude. So I'm just copying that file and pasting here. And I didn't put the folder on top like I did in the other case. So, okay, warnings, and what it displays is this. Whoops. This. Okay. So this is a sine wave, and that's should be the Fourier transform. And we see there x equal -5. Obviously, this data, this is the violin wave, and this is, and it got interpreted as two channels here. That's why two plots are being displayed. I recorded this as generated in Audacity using the generate generate tone function, which is mono. It's not stereo or two channels, left and right here. But anyways, I'm not Not at all sure what's going on there. I'm calling ft.fft on that same data. The only difference that's obvious is the difference in the way that the file is read using librosa.load. In the case here, I used webfile.read, which is from scipy.input output. And the number, anyways, curious if I'll care enough to try to figure that out.